Hey everyone. I'm going to wait. It's about 6 minutes. I'll start at 9 a.m. AEST. This is for everyone who watches it kind of later. So you won't hear anything for like 6 minutes, and then I'll start. everyone. I hope you can hear me. Let me just get all my ducks in a row. And I hope you guys are all well. It is so cold here. Hi, Simona. I was thinking about you because, can you hear me? I was thinking, because you said you were from Germany and it's like 1 a.m. in Germany at the moment. It's so late. So if you wanted to come to another one, I could move it to another time, if that makes sense. Anyway, let me know, because I could do, this is like 9 a.m. in the morning for me. It's at Sydney. Let me just check my windows, see. So I could do like a 4 p.m. Sydney time. And that would be like for, I suppose, Europe around Germany, that would be like 9 in the morning, but like 8 or 9. But I didn't know whether you guys were working at that time as well. Maybe you had to work. Well, yeah, that's what I thought. Like, okay, next week, if you want to come again next week, let me know. Let me know and I'll make it in the afternoon. We'll see if that's better for everyone else as well. It's hard. I take students from, when I was doing, I'll start soon as well, but I used to take students from like London, and I had one in the US as well, and everyone's from different places and it can be a bit hard to schedule. Let's talk about Monopoly though. Hopefully you don't go to sleep. And I'd had another comment to focus on the learner index. So I'll definitely do that, and I'll just go through the basic model. But there's also a few extensions that we can do. So let me know as we go ahead, but I'll just do the basic model. And I suppose the idea is Monopoly is really the other extreme from perfect competition. So we have perfect competition on one hand. There's many firms and many consumers and just lots of competition. And then there's the question of what happens when there's no competition. There's just one person, one firm in the market. And there's a few ways to characterize the difference. But I had a problem to go through. So let's just go through the problem, and I'll have a look at the chat board like every now and then to see if there's questions. I've only got a little laptop here, so I don't have heaps of space. Okay, so we're going to say that our monopolist faces the demand curve. So I'm going to put quantity demanded. That's a fairly standard notation, but maybe, I don't know, you might see other things for quantity, but that's how much is produced or is demanded, is equal to 100 minus 2p. Now, one thing to I'll say I do teach game theory. Yeah, yep, I know game theory. Yeah. Now, one thing about this one with Monopoly is that this is called a demand curve. We're going to relate quantity to the price. So if you had what's called functional notation, which is very common in economics, but at the beginner levels, it's not always, or we don't always express what's going on like this, but we might say quantity is being modeled as a function of price. So we use this function notation. And we would talk about that as a demand function. When we come to monopolies, it's very common, or sometimes easier, to have it in the form of what's an inverse demand function. Inverse demand. So we're going to put price as a function of quantity. So that's the first thing I'm going to do. So if we just take away 100 from both sides, minus 100 is equal to negative 2p. And then we divide both sides by negative 2. We have p is equal to negative 100 divided by negative 2 is 50 minus qd on 2. So these two equations, they describe exactly the same curve. If we had always have quantity on the horizontal and price on the vertical. These two equations, this one and this one, they describe the same curve, but it's just one has price on the left-hand side isolated. And in Monopoly, it's useful to have it in this form as an inverse demand curve. And there's some tricks that we do around this inverse demand curve with Monopoly. So let's just draw out this curve anyway. So if quantity demanded is equal to 0, then price is equal to 50 minus 0 over 2, so 50. So that's going to be if quantity is equal to 0. Let me know if I'm going too slow or too fast. Then that's 50. If price is equal to 0, we're finding our quantity axis intercept, then we could easily just use this demand function to do it and see that it's going to be 100, or we can use this one. Let's just use this form. Let me know if it just doesn't make sense. Let me know. 100 minus 2 times 0 is equal to 100. Okay, so this is our downward sloping demand curve. Where's my ruler? There we go. Okay, so that's our downward sloping demand curve. Excuse me, that's not very good. There is better. Kind of. That's okay. And then we have our downward sloping demand curve. And that's really one of the principal differences between monopolists and perfect competition is that the monopolist directly faces this demand curve. I'll explain, nothing there. Explain what I mean in a minute, but there's a downward sloping demand curve. And this is the constraint for the monopolist. Sloping demand. Because, why is it a constraint? Because what does this demand curve tell us? That tells us that if the price is very high, let's say we set the price here, then the quantity that we can sell is here. If we lower our price, say to P prime, we can sell more. So the monopolist, unlike the firm in perfect competition that is a price taker, it's a price maker. It has to choose which price, and in choosing which price, it's going to set how much it can sell in the market. So the downward sloping demand curve is actually the constraint for the monopolist. The monopolist can't put any price, like it can't do a price here above 50, and if it puts its price really high, then how much it's going to sell is much less than if it lowers its price. But then, of course, if it lowers its price, then the price per unit that it can sell at is very low. So it gets kind of less, perhaps, total revenue. So that the monopolist faces this choice is a huge difference. It is a price taker. I'll put this up here in red. It's a price maker. Price maker. It doesn't just choose the price. We know, if you know from perfect competition, the price is determined in the market at the intersection of market demand and supply. Here, our monopolist is a price maker. It has this really important choice, which is what price to choose. So that's really the hallmark of monopoly power. The thing that confuses me is, are we assuming the monopolist knows about the demand curve given any price, right? Yeah, we assume that the monopolist kind of understands this, or understands the position. Or maybe we can say that we're modeling, in our model of decision making, our monopolist has full information of the demand curve. But in real life, what that looks like is that they understand that if they drop the price a little bit, that their quantity is going to increase, and they kind of do it in an iterative manner, or bit by bit over time until they find that sweet spot. Does that make sense? Let me know. The question is here, then what price? What price to set? What price and quantity bundle is best? And we're going to maximize profit. So we want to maximize profit. Profit, I'm just going to use big pi. And we do that, let me know if this is okay, or I can show you a quick proof. We're going to set quantity such that marginal revenue is equal to marginal cost. Okay, that's great. Okay, good. So do you guys need any more discussion over this? Do you need more discussion over this condition? Marginal revenue is equal to marginal cost. That's going to maximize profit. That's true for all types of firm types. That's true for your perfectly competitive firm. It's true for the monopolist, for the monopolistic competition. Let me know if that's okay. So marginal revenue is equal to marginal cost. That's profit maximization. So we have demand here. So we need marginal revenue and we need marginal cost. Now marginal cost will be given to you. So I have in my question, the marginal cost is equal to 5 plus Q over 2. We're just going to use that. Oh yeah, did you talk about this in your videos? If not, then it would help. About this equation, marginal revenue is equal to marginal cost. Yeah, there's a few ways that we can motivate this. This is a very important. There's and this idea that we evaluate things at the margin. You know, with economics, when you're talking to people about what we try and do, we say, you know, we weigh the benefits and the costs, right? Benefits v costs. And that's what we do really in our models for forever. This is really what we do. We think about each decision that we could make, each marginal unit, and we say, is the benefits greater than the costs? And the costs here are opportunity costs, right? So it's a very full measure of costs. But that's kind of beside the point. The marginal revenue here is the benefit for the firm. The marginal, that's just means next or additional revenue. That's the money that they get. So what the idea is that we're going to think about each successive unit as we're increasing quantity here. And we're going to think, is the revenue that I get for making this unit, is that higher than the cost of making that unit? And if the answer is yes, so is marginal revenue greater than marginal cost, or greater than or equal to marginal cost? And if the answer is yes, then we get kind of this profit at the margin. You know, the revenue we get is greater than the cost. So yes, we should definitely produce that unit. When we're thinking about modeling the choices of consumers or of people, we might think about marginal benefit rather than marginal revenue. We would still think about marginal cost. So the idea is that we keep on going with our production as long as the revenue is greater than the cost. And we have to exhaust all of that because we want to maximize our profit. So we want to make sure that the marginal revenue, you know, we get every single unit that we can where the marginal revenue is greater than the marginal cost. And so we're going to exhaust this until we get to the equality, basically. Marginal revenue is equal to marginal cost. So that's one way of motivating it. Another one is just do some calculus. So profit is equal to total revenue minus total cost. We want to maximize profit. So we're going to find, if we want to maximize a function, if we think about a function, looks like that, for instance. The top of this function is where the slope is equal to 0. That's a maximum. So we take the derivative of profit with respect to quantity, because we're thinking about as you increase quantity on the horizontal axis here. So then that will be the derivative of total revenue with respect to quantity minus the derivative of total cost with respect to quantity. Sorry, it's a bit squashed. Well, the derivative of total revenue with respect to quantity is equal to marginal revenue. The derivative of total cost with respect to quantity is marginal cost. And then to get that maximum, so the first derivative is going to tell us about the slope of a function. To get the maximum of a function, or the minimum, but we're not going to worry about that at this level. But if we want to find the maximum of where that is the highest, we're going to set that slope equal to 0. So we set the derivative equal to 0. So we have marginal revenue minus marginal cost is equal to 0. If we plus marginal cost to both sides of the equality, we get marginal revenue is equal to marginal cost. Does that make sense? So that's another way to understand this equation. Another way is just visually. So let's find marginal revenue for this function and also marginal cost, which I've got 5 plus q over 2. So this is this is a linear equation, and you can see that the price slash kind of cost axes, if quantity is 0, this is going to be 5, so it's going to be here. And I'll get my ruler again. There it is. It's going to be an upward sloping function with a slope of 1/2. So something like, yeah, maybe like that. So that's going to be kind of marginal cost. Marginal cost. Now, is that okay with you guys? 5 plus q over 2. The slope is 1/2. And the y-axis intercept is 5. I'll take away this downward sloping demand, though it is super important, because that's really what differentiates what's going on in monopoly from what's going on in, here we go, in perfect competition. Okay, good. So marginal revenue is equal to marginal cost. So if you're ever stuck with anything, perfect competition, monopoly, a choice of a consumer, just think benefits versus costs at the margin. Benefits versus cost margin. Okay, so that's our marginal cost. Let's find our marginal revenue. And this is where it's good to have the equation of your line in that inverse demand with P on the left-hand side. Because it happens to be the case that marginal revenue is equal to the same intercept as our demand. So 50 in this case. And then we're going to double the slope. So the slope here of this demand curve is -1/2. So -1/2 times 2 is just -1. So it would be 50 minus q. I can show you an example of why that's the case. Actually, I can do it here now, but that's a shortcut. It's a very useful shortcut. And it means that marginal revenue, it'll have twice the slope as demand, but the same price axis intercept. And so it will come through like this, marginal revenue. And the horizontal axis intercept will be exactly halfway between the origin and the intercept of your demand curve. So it'll be something like that. And we pray to to whoever is that the diagram is not too bad. I think it's okay. Actually, I think the marginal revenue is not. I think I have to make it a bit flatter, given how things are going to go later. But it's okay. It's easier, I suppose. Oh no, it's okay. We'll just do it like that. It's okay. It might be a little bit out of scale. 50. Okay. Very good. So we have our marginal revenue. The question of profit maximization is thinking you for each Q as we increase quantity, the marginal revenue is greater than the marginal cost of production. So yes, we should make that one. We should make and sell that one. The marginal revenue is greater than the marginal cost. Marginal revenue is greater than the marginal cost. So that's the idea. Oh, actually, can we do that? I'll return to that. But anyway, you accept this condition, which is good. So here the trick is the marginal revenue has doubled the slope of demand and same axis intercept. Okay, so I'll just clear everything and kind of show you why that's the case, or give you, so marginal revenue is equal to the derivative of total revenue with respect to quantity. Total revenue is equal to price times quantity. That's it. Okay, so we had our note that we have to take the derivative of this total revenue with respect to quantity, and we know that price itself is a function of quantity. So what we can do, we have that inverse demand curve that was 50 minus Q on 2. So we could either use the product rule because we have two functions that are a function of Q and we want to take the derivative of this guy, but also we can just easily just substitute this in, okay? Substitute, and we see that 50 minus Q on 2 times Q, that's total revenue, right? We've substituted it in. And so then we can take the derivative of total revenue with respect to quantity. So yeah, I'll open this up. That'll be 50Q minus Q squared over 2. So we can take the derivative of this total revenue function with respect to quantity quite easily. So that will be 50 minus, the 2 comes in front, 2Q over 2 is equal to 50 minus Q. So the same intercept as demand, double the slope. So that's just a trick. Okay, good. So that's marginal revenue. We found marginal revenue. Marginal cost will be given to you, most likely, or you find it by taking the derivative of total cost. And then we're going to isolate that point where they meet, they meet, and the quantity that corresponds to that is going to be the quantity that maximizes our profit. So I'll just take this one away. Okay. Let's put here, set marginal revenue is equal to marginal cost. Well, we know marginal revenue, it's 50 minus Q. And we know marginal cost is 5 plus Q over 2. Okay. And then we're just going to solve for Q. So we can take away 5 from both sides, 45, and we can plus Q to both sides is equal to Q on 2. We still have that on the right-hand side, plus Q. Q on 2 plus Q, well, I can't add these up if they have different denominators. So I'm going to multiply Q by 2 on 2. And that means that we have the same denominator. So we have 3Q on 2 is equal to 45. 2 times 45 is 90 divided by 3, and we see Q star is equal to 30. There. Okay, let me know if that's too slow, too fast, anything not clear. That's 30. Okay, so we always choose our quantity such that we are equalizing marginal revenue and marginal cost. In order to find the price, we're going to charge as much as we can. Because we're a monopolist, we can do what, we can take advantage of everything. So we are going to, what tells us about the relationship between price and quantity is the demand curve. So we're going to read up, and that price there will be the highest price that we can charge for this quantity, given this demand curve. This is our constraint for the monopolist, is the demand curve. So the price here, we're going to sub this quantity into demand. Sub into demand. So our demand, we can just use our inverse demand curve. P is equal to 50 minus 30. So I'm just using this just to be clear to everyone. Sorry if it's messy. Our quantity is 30 divided by 2. 30 divided by 2 is 15. So the price is 35. Okay, so that's the maximum of what we can do. Okay, how's everything going? It's okay? All right, so what do we see? So that's the basic model of monopoly. It's pretty easy. The next thing that we can do a few things, but the next thing I think is welfare analysis. So understand consumer surplus, producer surplus, and that sort of thing. So let me know if there's anything that you want me to do in particular. Let's do welfare. We'll do welfare analysis. And then we'll do the learner index. That was for another viewer. Okay. Okay. Very good. So we have our picture. And let me know if I can probably address some game theory now if you wanted as well. Okay, so we're going to think about welfare, which is how well, the question of, okay, I'll just have a look at this. 35 is the price that consumers, that's the maximum that they'll pay. The demand curve can be interpreted as telling us that, the highest willingness to pay for if they want to pay 30 units. $35 per unit. So that's how we find. So our welfare analysis is important for economics because remember the fundamental question of economics is how do we allocate our scarce resources? We could do lots of things to allocate resources, right? We could give everyone an equal share. We could just divide everything up equally and give everyone the same thing if that was kind of technologically possible. We could give everything to a king and let them decide, or we could have a lottery. But in economics, for the most part, we study markets where we have an interaction between buyer and seller. And that interaction, there's a trade where there is a price and there's a price put on a good. And that is really, this price is the thing that tells us about who gets what. Because if you look at this demand curve, who in this market is getting this stuff, whatever it is? It's these guys up here. It's not these guys, right? These guys, the price is too high. So when we're studying the determination of prices and quantities, we're really thinking about this question of, in our world, who gets what. So this is where welfare analysis is just one. Perfect competition. In microeconomics. Okay, I can talk about that. Game theory. Game theory can tell us about interactions, but so in any case, so let's do welfare. We're going to do consumer surplus is equal to, we're going to take the sum of the area. I'll do it in pink. The area will be the area below the demand curve above the price. So the idea, when we're thinking about the allocation of scarce resources, and we go, how good is this allocation, right? We're going, how can I measure the value of this allocation? Given that we're studying the allocation of scarce resources, we're saying, well, in this world, the price of this good is $35. So these guys get it, these guys don't, and this much of it is made. And, the resources in our world that are all scarce, some of those go towards, kind of 30 of this, whatever it is. And you say, is that a good allocation? And so consumer surplus will tell us, okay, well, like these guys, up here, there's something, because it's all voluntary trade. So these guys would have paid up here. That's the value that they put on that good. They would have paid this much. To say we're doing 30 units at $35, that's $35 each. So even the guys who were up here with their demand, they would have paid right up here, but they didn't have to because of the way this market operates. They only had to pay this much. They didn't have to pay close to 50. They only had to pay this much. So we take the difference between how much they would have been willing to pay and how much they actually had to pay. And we say, okay, that's good for the consumer, that difference. It's good to have a big difference between how much you were willing to pay and how much you actually had to pay. So we're going to sum up these differences below the demand curve above the price, and that's going to be our consumer surplus. So it's just the area of a triangle. Half times the base is 30. and the height is 15, which is equal to 225. Check that. The producer surplus has a very similar interpretation in terms of why we care about it. We care about allocation. And so we say, how are the producers doing given that the market is set up this way? And we say, well, the marginal cost of production for, this unit was down here. But again, every unit is being sold at 35. So our producers didn't have to sell it at the marginal cost. They got more than the marginal cost. So we take the difference between here and here, and we say that's good for the producer that there's that difference. And we get that difference all the way up to Q is equal to 30. We take the sum of the differences between the marginal cost and the price, and that's producer surplus. So this one is going to be 675. We're going to do, this is the way I'm going to do it. I don't know if there's a better way to do it, but I always say, okay, this is going to be a rectangle plus a triangle. Plus a triangle. So I just need to know the height of here to get the lower bounds of our rectangle and the upper bounds of our triangle. So I evaluate to do here if Q is equal to 30, what's marginal cost and what's marginal revenue? We can do either, they're equal at that point. Marginal cost is equal to 5 plus Q over 2, 5 plus 30 over 2 is equal to 20. Is equal to 20. Let's say, yeah. So the guys with higher reservation price are having a surplus, and other consumers, yeah, they don't get the stuff. Yeah, that's right. So it's it is really about, it's a very simple model of allocation, but it tells us about who gets what. So it's cool. It's just, there's so little, but there's a lot to think about, isn't there, sometimes? Yeah, these guys don't get the stuff. And you think that's fine, but when it comes to things like housing, or something like that, you go, okay, So, there's different markets that we can think of, right? I don't know, housing in Australia is terrible at the moment. I don't know what it's like, where you guys are in Germany. Good. So we've said that this is here. So the rectangle is going to be 15 times 30. 15 times 30 plus half times, that's 15 times 30. 15 times 30. And I think here, the 675. That's there. Okay, the last one with the welfare is our deadweight loss, which is going to be here. And the question is, why is deadweight loss here? Deadweight loss. Okay, well, our demand curve, did you guys get this? Let me know. It's like the marginal benefit of consumption, or the highest willing to pay, or as you said, the reservation price. So the idea is in a market, what we want to be doing, if we want to be like efficient, we are going to so efficiency requires that we exhaust all quantities for which the marginal benefit of consumption, so the enjoyment, is greater than or equal to the marginal cost of production. So the idea is, well, we have this world full of scarce resources. What's the best way to allocate these resources? And the answer is, well, we should be making sure that everything that we produce and sell and what we do with our resources, the marginal benefit is greater than or equal to the marginal cost. That's fair. But we're going to exhaust all of them. So here the problem is with the monopolies that it sets sets the price so high, and there's all these units here where the marginal cost of production is lower than the marginal benefit or that valuation of how much the consumer would enjoy that good, but they're not producing it because the price is too high essentially. So that's going to be deadweight loss. To find deadweight loss, we need to find this point here. This is where my diagram's going to get a little bit skewed. So to find this point, we set demand equal to marginal cost. Set demand equal to marginal cost. And so our demand is, we're going to use that inverse demand function again with P on the left-hand side. So 50 minus Q on 2 is equal to, it was 5 plus 30 over, Q over 2. Q over 2. So then we can plus Q over 2 to both sides and take away 5 from both sides, and 45 is equal to Q. Tell me if that's too fast. So at the equilibrium, at the market equilibrium here, we are not efficient in that sense that we are exhausting all of the gains from trade. It's only at the equilibrium in perfect competition. Yeah. Of course, without the government and taxes. Oh yeah, even in a monopoly, well, it would depend. If you had something, you probably haven't done it yet, but if you had something like, if the monopolist was producing something that you didn't want a lot of, like cigarettes or something, or something that you thought that you thought you wanted to, or that there was, maybe cigarettes because there's what we call an externality, but I think that that's a bit, you're probably not there yet if you're just doing game theory, but it's not equilibrium, it's not efficient because we have this deadweight loss. So the deadweight loss, we find this quantity associated. Now, if we were here, we would be efficient. If we were producing 45, this is where my diagram gets a bit wrong, sorry. But that's the idea. So we should be producing 45 if we want to be efficient, because then we would exhaust all. But the market equilibrium here underproduces relative to the optimum, to the social optimum, we call. Yeah, is it good? Is it okay? Good. Okay, so that's, anyway, that's 45. This is another triangle. So it's half times, you can just take the base here as 15 times 15 equal 2.5. So that's the deadweight loss. Oh, good. So there's the question of the deadweight, it's the question of the welfare, like just finding the areas. But then there's that deeper interpretation of what's going on. All right, we can do the learner index now, but I'll just, the game theory. Game theory is a particularly popular at the moment because it's just, I mean, it's a very interesting way of modeling, and it's a little bit different from what we do here, but there are some games that consolidate some of the stuff we do, like between perfect competition and monopoly as well. So it's very interesting, I have to say. But you can get whole classes which are just microeconomic, just game theory. Yeah. Okay, let's do one last. I'm just going to go through the learner index, but if you have any specific questions on game theory, feel free to ask now if you have anything specific. I do have a few fairly popular videos on game theory, and I recently did one on mixed strategies and infinite repetition, if you guys are doing that. So yes. Okay, so let's think about, I'm not sure if you're Simone, feel free to go if you're not doing the learner index and you want to go to sleep. Feel free. Learner rule. It comes from learner index. Learner rule. This is going to be a measure of markup. Measure of markup. So we see here that our monopolist has set the price above marginal cost. And so that's going to be, we call that markup, the ability to mark up over costs. No worries. Oh, negative externality. Okay. I'll do this. I'm just going to answer TK. Only got like a little chat thing. TK, the negative externalities. So, I don't know if you guys have done it yet, but if you guys are up to, I think different parts of the world are up to different sorts of things, aren't they? But let's say you had quantity and price. The thing about the market interactions between our buyers and sellers is that it only includes our buyers and sellers, right? So this whole idea of the welfare, we're talking about marginal benefit and marginal cost, and make sure we exhaust all levels of production where marginal benefit is greater than marginal cost. The problem is that we're only really including in this analysis kind of the marginal benefit of the consumer and the marginal cost of the producer, but we're not including in that analysis the idea that there might be third parties that are affected by the trade, either by the consumption or the production of a good. So if we go here, so there might be a third party who's got nothing to do with the trade, right? Like just someone downstream from the factory. Or with the cigarettes, I was thinking, what do you call secondhand smoke, where someone else is smoking around and it bothers a third person. The cost of, there is an additional cost there to a third person. So it's called externalities. Externalities. So there is a third party other than the buyer or the seller. The buyer or the seller or the producer, put producer, who is affected by the trade, by the way that we've set up this market, by the way we've allocated the goods. And it could be in a positive way, in which case we have a positive externality, or it could be in a negative way where we have a negative externality. And then once we do this, we can build in some deeper concepts of benefit and cost, and we can talk about what we call social benefit curves, benefits, and social costs. And social benefits is going to be equal to the marginal benefit of consumption by the consumer. Say the person who is having the cigarette, they really like having the cigarette, they get some benefit from it. But it's going to add on any externalities, about that consumption. And those externalities can be negative or positive. So you could have a negative externality here, which means that once we're tracking the marginal benefit of consumption, it's actually less than what the demand curve implies. Social cost. I don't know. Oh, yes. Okay, good. You understand? So, and you can have like the social cost as well. The social cost will, you can have a social cost curve. And again, that will be the marginal cost of production plus any externalities. And you can have positive and negative externalities that are associated with the production of a good, if that makes sense. So then if we look at our monopoly, what's happening with our monopoly? We have a demand curve, which is what the consumers, let's say it's for cigarettes. What's another good one? What are we kind of limiting? Or maybe the inhalers, what do you call them? The vaping. So we have a demand for vaping. Or I think that's more common than smoking cigarettes now. And the demand curve can be interpreted as tracking the marginal benefit of consumption, or to say it another way, the kind of willingness to pay for each marginal unit. So that's like a valuation of how much those units are worth to the consumer. So that's what the demand curve tells us. And then we have a marginal cost function, and that's the cost of production. So that's marginal cost. And when we have a monopoly, we do marginal revenue, which comes through like this. And so what ends up happening is that we underproduce relative to where marginal cost is equal to marginal benefit. We kind of produce here, and usually that leads to deadweight loss. So that's what we've just kind of gone through. My point about the cigarettes was that, okay, well, imagine that there's a cost associated with the consumption of the cigarettes. So there's a third party that's affected. Well, then once we add that into we have a fuller measure of what counts as demand, what counts as benefit. We have our social benefit. For every unit, it's actually less than we thought. It's actually less than we thought. Maybe it's down here or something, because the harm to the third party is really a lot. So the marginal benefit is actually less than we thought. Say it's here. So our social marginal benefit of consumption is down here. Well, then efficiency, as long as this cost is, there's no other externalities in costs, well, then efficiency would require us to only produce up to here, if that makes sense. So we wouldn't want to be producing all the way up here. So for these sorts of industries, we might tolerate a monopoly. We might like it because it brings the quantity that's produced in a market kind of closer to the true equilibrium where we're equalizing the costs and benefits of what's going on. Does that make sense? I'll give you a few minutes to let me know if that makes sense. So the idea is that we might think more deeply about costs and benefits, and we might include third parties that are affected by the trade. And so our benefit curve might actually be lower down than we thought. For each marginal unit, the benefit is less than we thought, because we've got the benefit to the consumer, but then there's some harm. Yeah, I don't know with Crown. Yeah, what's Hydro Company? I don't know Crown. Like Crown, like the Crown, the gambling. Is that the one you mean? I've lost my words. Where do you go to gamble? You go to a casino. Crown, like the casino. Perhaps that could be the reason why. I don't know. I don't know about the gambling. Yeah, I don't know. Hydroelectricity. Oh, yeah, okay. That's going to be a little bit different. I think that's going to be a little bit different because here we're talking about a negative externality. With hydroelectricity, we're talking about what might be a natural monopoly, what we might call a natural monopoly, and with railways as well. And the idea with railways is that, with railways, you don't want to. I haven't taught natural monopoly in a long time. You don't want like a million different providers providing a railway, right? Because each of them, like each of the, we all experience that with the outlets to our devices, right? They're often different types of cords. And it's so inefficient. If only everyone would adopt the same outlet so I could charge all my devices on one thing or something like that. We don't want our railway kind of going through our countries. We don't want like 6 of the railway tracks, right? Corresponding to however many companies we have doing the railway. We just kind of don't want that. So what we do, this is what we call a natural monopoly, where it's just natural to have just one person or one company providing that service. The problem is with natural monopolies is that they're quite expensive. They have really, really high costs. but we still need them. So often in that case, they are government funded. Yeah. This one would be if, when we're thinking about the monopoly, we just a standard monopoly rather than a natural monopoly. I can get the diagram for you. I just haven't seen it in such a long time. I'll just need to go get my book. But the idea with this is that there's a third party other than the buyer who's affected, like with cigarettes and secondhand smoke. And actually, so it will be optimal to have less than, you don't want perfect competition there. You don't want like low prices for cigarettes. You would like high prices for cigarettes because you want to limit how much is consumed anyway. That might be one reason why we might tolerate a monopoly. Let me know if that helps. Okay, I'll wait for that answer. Before then, I'm just going to quickly go through the learner index. So I said before, if you guys were around, that we have this profit maximizing condition, marginal revenue is equal to marginal cost. And that's our profit maximization. Okay, let's focus on this term here. Total revenue is equal to price times quantity. So if we want marginal revenue, we have to take the derivative of total revenue. Does that make sense? Yeah, good. Okay, I hope that makes sense. Let me know if you want, because the natural monopoly diagram is, and the average costs or the marginal cost, or I can't remember, is always higher than, so you need government regulation here. I can't quite remember the story. I'm embarrassed that I don't remember the story, but anyway, maybe if I do another one, another live stream, I can do it. Okay, so I'll go on to the learner index unless anyone wants me to review anything else. But so marginal revenue is the derivative of total revenue, and derivative of total revenue with respect to quantity is equal to, and I'm just going to very abstractly use the product rule here because we have price times quantity, but price itself is a function of quantity. So we have two functions that are a function of quantity. So when we take the derivative with respect to this guy, we're going to think about them as two functions multiplied together. So we take the derivative of P with respect to Q times by Q plus the derivative of Q with respect to Q times by P. Okay, dq is just equal to 1. So we're left with, and actually I'm going to put the P on the left hand side because everyone does. I don't know why. P, oh no, I know why. P and then plus this guy, dp dq times Q. So this is marginal revenue. Excuse me. Okay, so we can substitute this in. Oh, actually, the next thing I'll do, sorry, I got ahead of myself. Price elasticity of demand is dq dp times P over Q. So this price elasticity of demand looks suspiciously like this guy, right? But a bit different. So dq and dp are swapped, and we also need another P. So what I'm going to do is I'm going to multiply this by P on P here. And then note that, well, so I get P plus dp dq times, I can put Q and P, Q over P times P together, right? That's okay. All right, well then this thing looks like the inverse of this thing, the elasticity. So if we have, so therefore, I don't know how to spell, I think that's okay. Therefore, 1 over our price elasticity of demand is equal to, I'm just going to dp dq, just swap these guys, times Q over P, which is this, okay? And so then what I'm going to do is I'm going to put P outside some brackets. I get 1 plus our inverse, and P comes out here again, but we've got our inverse of our price elasticity of demand. Okay, so that's marginal revenue in terms of elasticity. Good, so now I can substitute this in. Sub into marginal revenue is equal to marginal cost. So I have P 1 plus 1 over epsilon P. That's price elasticity of demand. Sometimes you might see that ED or epsilon D, price elasticity of demand, is equal to MC. Okay, what do I do now? Okay, I can P over P, yeah, and then price over, oh, I can put the price back in. Sorry, I was here is equal to MC. Okay, and then I'm going to take away price from both sides. So I have price over our price elasticity of demand is equal to MC minus P. And then I feel like I've done something. Oh, it's okay. If I've done some maths wrong here, incorrectly. P. No, it's okay. It will come up to the same. There's going to be a negative missing. P over P. Yeah, I'm going to do it another way. My apologies. Sometimes when you're presenting, I got no excuse for it. Sometimes you just make mistakes. It's okay to make mistakes every now and then. Okay, so I'm going to, yes, I'm going to take away P over epsilon P from both sides and take away MC over, yeah, that's what I'll do. So it's P minus MC is equal to P over epsilon P negative. There you go. I'm good, everyone. Then I'm going to divide by P. So I get P minus MC over P is equal to the negative of our price elasticity of demand. Okay, so this is what we call the Lerner index. Lerner index, and it's a measure of markup index. Okay, and so we know if our price elasticity of demand for our good, and I suppose the reason why I needed the negative there is because epsilon P will come out as negative, and so then we get a positive. But interesting kind of applications here is we know that if our elasticity of demand is very steep, so if we have a very steep demand curve, then the firm has kind of more market power, what we would call. And the flatter it gets, the closer it gets to perfect competition. See? No. So the steeper, the higher the elasticity, and the higher the markup will be. So P minus MC, that's price minus marginal cost, that's markup. But here we've divided out P. So why is that important? Is because if you had a good that was very cheap, like a small thing, then the price and the marginal cost, the difference between it is going to be very small. But if you had a very large thing, like a car, the difference between price and marginal cost will be pretty large. But we don't want the size of the thing, essentially, dictating the value of the markup. Really, so we divide out the price here. So we get this measure of markup that's independent of the price, whether a thing is kind of expensive or very cheap, if that makes sense. We really want this measure of markup to be how much over marginal cost have we been able to? And we want to be able to compare them between different goods. So that's one cool thing about this, is that we can divide out the price. Let's see if for perfect competition, price is equal to marginal cost, right? That's one of our outcomes of perfect competition. So we get 0 over P because price is equal to marginal cost. So this is equal to 0. We have 0 markup. Okay, well, what would be the other? So that's one. That's kind of the lower extent as we get closer to perfect competition. As the price gets closer to the marginal cost, the value of our learner index will get closer to zero. On the other hand, if the marginal cost was zero, so the price was basically, there was the maximum amount above marginal cost that you could be, then P over P is going to be equal to 1. So at the maximum, the index is going to be equal to 1. So the index goes from 0 to 1, with 1 being more, the most that you can be above marginal costs. And we can see that when marginal cost is 0. Okay, so that's learner index. Is there any, I don't know if anyone's left in the room. I'll check. I haven't checked it in a while. Yes, I've got a few people in the room next. Is there anything that anyone wants me to talk about? Or hello? Is there anything? Oh, I see my screen has been cut off at the top. I think it's okay. Hello. So is everyone enjoying economics? What time is it wherever you are? I'm pretty sure I have a subscriber, he's from Germany, and I was like, go to bed because it's like 1 o'clock in the morning. So if I do another one, I'm going to do it, I think, later in the day for me. So maybe is it really a terrible time for you guys, or are you guys in Australia? It's so cold here. Otherwise, I think I'm probably going to log off. But let me know, do you guys need help with anything? 5 p.m. in Canada. Oh, cool. Is it cold there? It's like 10 degrees here. I think it's about 10 or 12 degrees. Celsius? Do you guys use Celsius? Which is so cold. But apparently I think that's warm for a lot of the world. Oh, cool. 7 a.m. in Indonesia. So if I did one like 6 or 7 hours from now, that would work for you guys. Hello. And when is your exams? This is like my lull for the year. Like, not, I've got very low views at the moment, and it's usually around in a few weeks it'll probably pick up. Maybe because I get a lot of American viewers. Anyway. Okay, well, if you guys don't want me to cover any more material, but I'll probably do another one next week if you guys want me to. So, but I might just do it a bit later in the day. So it's not like 1 a.m. for my subscriber who's kind of coming quite a lot. And let me know what you want me to do. Is it game theory? Everyone's after game theory these days. Really? Oh, thanks. You're so sweet. It's really my pleasure. I really like talking about it. I like yeah, I do like talking about economics. All right. So Monopoly topic gets people on exams, really? Yeah, I suppose there's the things. Oh, international trade. I did a unit back in. Like, international trade, do you mean, I'll just do my thing. I'm worried my screen has been cut off so much, and I didn't realize, because my little laptop's very small. But so do you just mean like this one, where you have like this one with the trade, where you have domestic supply and domestic demand, and then you have a world price? And whether it's under or over. Is that the one you mean? Oh, you can see everything. Oh, that's good. Is this the one you mean on international trade? Or do you mean like, if you got that book I was looking at today, I was like, oh no, that's so hard. The Feenstra, the international, I remember doing this as advanced. I've got it here, advanced international trade. And the like Hesher-Ohlin model, was it those ones? I haven't done that in years. Oh, really? So, labour migration. That's really hard stuff. Ah, Herschel Olin. I know. I gotta do that one. What textbook are you using for the Herschel Olin? Oh God, because I was looking at the. Are you doing vectors? I haven't done that in a long time. Oh yeah, competition. Oh, yesterday was the exam. Cool. Did you do okay? It's the Herschel Olin. I have to. This might take me a while though. Henry Tsao. So, maybe I can try. If I do anything on international, it will be like maybe a couple of weeks. Give me a couple of weeks to organize it. I don't know what level you guys are doing at it. If you're in this live stream, you're probably not like a really high level. But I don't know. Yeah, I haven't done that in a while. But I can try. Watch this space. I'll try. Is that it? Does anyone want it? So international trade. I'll have a think. Labour migration. So yesterday was just a day for the exam. Anyway, good luck with your exams and everything. It's, you know, whatever happens, happens. If you're at the beginnings. Oh yeah, the professors, the economic professors, I think they don't care much about the. I've heard this from. Well, I don't think that they don't really. They like, I think, the research. They like doing the research, so they. I think that they don't really care sometimes for the, or that they've been doing it for such a long time, which I think I'm worried that I do. Yeah, I think so. Like maybe that they, you know, they prefer the research, or especially. Oh, okay, yeah. Especially like the, you know, if you get asked, like some people think, I think especially with the mathematics, that if you get like a person in their 20s who doesn't understand mathematics, then they must be, you know, they get sick of them or something. But it's not that. I don't think it's like that at all. I think lots of people just haven't had the right opportunity to learn it, and if they do, so then they get sick of being asked like maths questions, I think. Okay, international trade yesterday. Open IEO. Okay, I'll have a look. Yeah, I'll have a look. I haven't taught international trade I don't think I've ever taught international trade. Like, I don't think I've ever had a student who's been doing international trade, or I've never done it, except for this very like simple model that you see here, which is just commonplace in first years. But I'll have a look. Yeah, I think YouTube should be better with the search function. Do you reckon? Like, you can search on my page, but yeah. All right, I'll have a look at that question. And you can always, my email is econmathhelp@gmail.com. So you can always email me through stuff. So I'm just going to take a picture of that IEO website. Okay. All right, guys, have a good day, I suppose. So do you guys want me to do something next week? Maybe I'll put something on the community tab next week. I'll probably make it a little bit later in the day. Thank you. And then, you know, you can comment, or I can suggest a few topics. I'm not sure how I'm going to do about the international trade, but I can try. Yeah, or you can email me. All right, guys. Thank you so much for coming. Good luck with your studying. You can do it. I'll see you guys. Yeah, I'll see you guys maybe next week. Yeah, I'll try. I have a little bit of time now at the moment because my husband's can look after the kids, and then once they go into childcare, then I can do more. But that's going to be a little while. But I've got a little gap here where I can, which is good. All right. Anyway, you guys go study or have your breakfast, or wherever there was someone from Canada. So that will be dinner probably soon. Thank you guys. Okay, I'll shut everything off now. I'll just keep an eye on the community tab, and we can decide what you want to go through next week if you decide to come. All right, see you guys. Thank you so much for coming and talking to me. Thank you. Bye.